Okay, hi everyone. So today we're going to do a couple of topics that are back to related to lines. As we just did in our previous example, we're going to look at the slope, again, of a graph. And let's start here. So if I give you 2 points on a graph, now again, this is a graph that's already drawn for you. And I say, let's say I put a point here and a point here. So the ideal way of finding slope of a graph is you look for the nicest points possible. Look for the nice, make your life easy, okay? So in this one, I've made dots, but you could have picked any points along the way. You could have picked this value here, but look at this point. Is this a nice whole number? If this is 1, 2, 3, 1, 2, 3, 4, is my red dot, and let's make it red, is my red dot in a nice solid value, or is it more looking like a decimal? It's like a decimal. So the first trick here, very simple, pick nice points that cross the whole numbers as easy as possible. So in this case, we'll pick the dots I put. So we'll use, let's get rid of this guy here. Let's see if I can erase it. Nope. Try it again. I'm going to pick the 1 and I'm going to pick the 4 here. And we're going to walk our way up. So what's the rise? How to get from dot A to dot B? I went up how many spaces? Okay, just count it. 1, 2, 3, 4. My rise over run, which is a way for us to say slope, is simply just count rise, which is I went up 1, 2, 3, 4. And my run, how many spaces over from here to here, is 1, 2. If you don't want to count from the top, you can definitely count from the bottom. You could have said from here to here, it's 1, 2 spaces. And we went in a positive direction. So this becomes, oops, reducing it, 2 over 1, or the same thing as 2. Now, if I instead use 2 over 1, would this have looked like a whole number? Well, let's try it. If I go up 1, 2, and I go over 1 space, ooh, that's exactly on the line. So we can always rewrite our slopes. We can reduce our slope fractions, and those values will all fall on the line also. Now, if I had put this dot here to begin with, instead of going all the way up to 4, 1, 2, 3, 4, you could have gone 1, 2 instead. 2 over 1, which would have given us our same slope. If I go 2 over 1 again, 1, 2 over 1, that would have given us our last point. So the cool thing about slope is that the same slope that we start off with is the same slope that we're going to end on. The whole line has that same exact slope. Let's do this again. I'm going to draw you another picture. So I'm going to pick a point up here. Pick a point right here. Okay. So when they give you a graph, that's actually one of the easiest way to find the slope. We just have to remember the order of slope. It's always going to be rise over run. Okay, so rise though doesn't always have to be positive. If I lose value, that's going to be a negative rise. Or if I go backwards to the left, that's a negative run. So I want you guys to help me count here. And please don't think this is silly, but what is the rise from point A to point B? Do we have to go up or down to get from A to B? Okay, you're at the mall, your parents are on the A floor, you're on the B floor. Are they going to have to go up or down to come get you? So let's count it. I'm going to go 1 space, 2 space, 3 spaces, right? That's where we want to go. And then from A to B, we're going to go from 1 and 2. So we have a negative. How many spaces do we come down again? Let's count it. 1, 2, 3 spaces. That's my rise. I went down by 3 floors. And to get from A to B, Not from 0 over here. That's not what we're looking at. We're looking specifically at A. We get to go 1 and 2 spaces to the right, positive 2. But let's try something else. Let's go from B to A. If I go from B to A, would it still give me the same slope? So I'm going to change my color. Hopefully you're not colorblind like me. So let's use green. If I start from B, I'm going to go back to A. Would that give me the same slope? So to get from B to A, our rise and run. Let's do rise first. We always do rise over run. Slope is equal to rise over run. So we're going to go up 1 space, 2 space, 3 spaces to go up. That's a plus 3. My rise is plus 3. But careful here, what's my run? Am I going to go forward or backwards? I'm going to go backwards by 1, 2 spaces. That's a negative 2. Please compare our original answer to our new green answer, I guess you could say. Are they the same answer? Is negative 3 over 2 equal to 3 over negative 2? If we write the negative in front, yeah, they are. It turns out, to find the slope, it doesn't matter which order you use. Who says A has to be first? Who says B has to be first? Answer, it doesn't matter. Because A and B are points on the same exact line. So if they're the points on the same exact line, it doesn't matter who goes first. You can say they're all in the same family. It doesn't matter who goes first. We're all family here. Now we're going to do this one more way, a way that we learned before. And we learned it by, what is the slope of 2 points? The point is 1, 4 and 3, 1. 1, 4, that's point A, and 3, 1 is point B. And let's use our slope formula that we just did. Thank you, yeah. They are the same fraction, negative 3 over 2 and negative 3 over 2. So let's go ahead and use our slope equation. We can represent the slope with the letter M. That is another way of saying slope. I don't know why they use M. Maybe it's like for motion or movement or money. Huh? Money? So we're going to say x1, y1, x2, y2. And it's just to remind you that we always subtract our y's from our y's and our x's from our x's. Oops. So we'll follow the rule, y2 minus y1. Oops, that's a 4, not a y. Over x2, which is a 3, and x1, which is a 1. Okay, let me highlight that for you. The y's minus the x's. Sorry, divided by the x's. You have to say the same order. Now, what if you don't want to start off with y2? You could actually write it the other way. You could say 4 minus 1 over 1 minus 3. That's also okay. Look, I flipped the values, but I flipped them as a pair, right? I said y2 first, x2 first. In the second fraction, I said x1 first and y1 first. So as long as you flip them as a pair, the order doesn't matter. So let's take a look. This is going to be negative 3. 1 minus 4, more negatives means we have a negative value. 3 minus 1 is 2. Oh, that's our same answer here. If I go backwards, 4 minus 1 is 3, positive 3, and 1 minus 3 is a negative 2. Same dilemma we had, same answer. So these are the ways that we're looking at slope right now. We could find the slope using 2 points, or we can look at the graph and just count it out. What is my rise over my run? So in Excel, this will take you like maybe 2-3 minutes, as long as you're careful about counting your spaces. And these are our 2 main ways for us to find slope. There's actually one more main way, and that's from the equation of the actual graph. And we'll talk about that right now. So we've been talking about something called standard form. So here's our second part of the lesson, standard form. And this form was ax plus by equals to some number c, where the hint was this, that x's and y's are on the same side. X's and y's are friends. But today we're going to learn a new form, and this is called slope Y-intercept form. And this, by far, is the most popular form. Slope-intercept form and standard form. And slope-intercept form, by far, is like the number way we see lines. And slope-intercept form has its own pattern. It's not A, B, C anymore. We switch it with variables that actually mean specific things and tell us what the graph automatically looks like. So here's our equation. Y is equal to mx plus b. Now, we just said the letter M is going to stand for something. We just said that just a moment ago. Do you guys remember what the letter M stands for? Let me scroll back up slowly. M stands for slope. Turns out math people decided to, again, just use the letter M to define slope. Now, so M is your slope, and it's always changing with X. As X changes, that changes, M tells you how fast X is changing. If X is 1, 2, 3, M could totally change how fast these values change. Imagine M is almost like your multiplier. M is the value that's going to change your paycheck. Right? If you work at McDonald's, your M value is like 1, because you'll make like $10 one year, and next year you'll still make $10. And then the year after that, you make maybe $10.10. But if you're an engineer, your M value is like 1.5 to 2. One year you're making 30,000, next year you're making 45,000, next year you're making 60,000, right? So the M value multiplies our steps. Okay? The B value here, so I'm going to sneak that in there, is our Y-intercept. And we talked about the Y-intercept. The Y-intercept is where the graph runs in to your Y-axis. This is your Y-intercept. Sorry, I should make that point a little better. This point here is your Y-intercept, where the graph runs into the Y-axis. Okay, so let's look at an example here. Again, we have two parts of this line. We have the slope and the Y-intercept. Super important. These are going to tell us everything we need to know how to graph this. So here's my first example. Y is equal to 1 over 2x plus 1. Is this in standard form or in slope-intercept form? Here's a hint. Slope-intercept form is always y equals 2. Slope-intercept is always y equals, while standard form always has x and y on the same side. So slope-intercept form, you guys agree? That's slope-intercept form. If it's slope-intercept form, we can start labeling parts. The value next to x is what we call the slope. Thank you. And the part that we call the y-intercept is always by itself. I'll abbreviate that as y-int. No, I'll write it for now. Intercept. But I'll typically label it just y-int. Okay. So here is the crazy part about this. If I ask you to draw a stick figure with certain characteristics, okay? A stick figure with certain characteristics. First, if I say stick figure, I'm just gonna draw something like this, right? I'm gonna give this guy some characteristics. I'm gonna say, draw some glasses on him. Give him a frown. So what are the characteristics of this guy? Does he look happy or angry or sad? Well, he could be after sad or angry, right? What if I said, give him a piece of chalk. Draw him behind a blackboard. Hamilton, this is what I look like every single day. Oops, shouldn't have done that. Okay, so We're drawing the characteristics of this graph. On our little stick figure, characteristics, this guy wears glasses and isn't happy. Mr. Go. See, we're there. Maybe I should give myself headphones now. So we're going to graph these two parts. Now, you're going to graph the y-intercept first and the slope second. Why? Slope tells you how much you're changing, okay? But it doesn't tell you where to start. And that's what the y-intercept helps us do. So please take a look here. My y-intercept is 1. So when x's and y's, we want the y-intercept to be 1. Put a dot there. That's it. That's our first point. We have 1 point on the graph. Now, as a reminder to you, how many points do we need on a graph? We need 2 points, right? Thank you. So the slope tells us our directions to our next point. So my slope is 1/2, and my y-intercept, b, is 1. So we graph the 1. Now we have to graph the slope. Now remember, slope is rise over run. Let's go ahead and graph that. From the point that we drew already, on your paper, you should have put a dot at 1 already. You can draw a couple more tick marks if you want. We are going to rise 1 step. Let me change my color. I'm going to rise 1 step. And my run, we said, is +2. 1, 2. Now we have 2 points. That's all we're doing. We're going to do it one more time. From our second point, we're going to rise 1 step, and we're going to run 1, 2. And it's almost like we're dropping eggs along the way. As we walk, we're dropping little breadcrumbs, I guess, yeah, breadcrumbs. And we can draw a line now that goes through all 3 points. So let's see if this line follows the characteristics we just described. Does this line run into 1 as its y-intercept? Does this graph run into 1? Yes, it does. What is the slope of this graph? Is it rise 1, run 2? Rise 1, run 2? Yeah. Rise 1, run 2? Yeah. That is the equation of this line. So slope-intercept form is one of the easiest ways for us to graph a line. It tells us everything we need to know. Let's go on and do another example. Y is equal to -3/2x plus, let's do 2. When you have a slope-intercept form, you don't have to do a table. You don't have to plug in values. We're reading the characteristics. Just like on my little stick figure guy, what are the characteristics? So y is equal to, mx plus b. So my m and my b are already there. They're standing in broad daylight. You can spot them. X is always next to my slope. So my slope has to be m is -3/2. Make sure you take that negative sign. A negative slope doesn't mean I'm making money or losing money, right? Making money or losing money. And the negative slope means I'm going to be losing money. And my b value here is 2. Okay, so 1, 2, put a dot. Oh my, I did it too fast. Let me slow back down. Thank you. That's right, we're losing. So, okay, I did this too fast. My y-intercept is 2. So in my y direction, not my x direction, in my y direction, we're going to put a dot at 2. Now, if I put a dot over here, would this be considered my y-intercept? No, that's just some point, not floating off in space. Y-intercept is always running into this y-axis. It always runs into that wall. It always runs into the wall. So that's my first point. My next is follow the slope. My slope is -3/2. Rise, rise over run. So what's my rise? I see -3, right? So from this point, we're going to drop by 3 spaces. -1, 2, 3. What's the run? We said +2. 1, 2 to the right because it's positive. Put your dot, and we have 2 points. We can do this again if you want. We can count it again from our new point. Down 1, 2, 3, and then over 2 spaces. Hey, they all look like they're on the same line. That doesn't look too bad. Now we got one more thing. Who says the negative has to be on top? And the negative could be on bottom. And that's something they learn about fractions. If you have a negative sign, you can write that negative on top or bottom. Both are totally valid. So let's change it up. My rise is now a positive 3. That means it's going to be up. And my run is negative. That means it's going to go left. So let's try this. From our first point, let's count it. Let's go up. 1. Oops, let's use a different color. Go up 1, 2, 3. And our run is going to be back 2. 1, 2. Why did I go back 2? Because we said our run was a negative 2. Right? And that's important to us. A negative means we have to go back when we're running. Do those 4 points now look like they're on the same line? I hope so. As best as I can do, right? My human ability of drawing lines. Yeah, that's not bad, right? Don't forget, once you draw the line, draw arrows at the end of the line to tell everyone this line keeps on going forever. Okay, so let's go ahead and do this on IXL. I'll show you guys how fast this could be. So here's an example on your homework for IXL. Let's go ahead and take a snapshot real quick so we can write on it. So we have y is equal to 8x plus b. Our formula, y is equal to mx plus b. Right now, please tell me what my m is and what is my b is. M is slope, b is y-intercept. So what is the slope here? Would that be 8 or 1? What's your y-intercept? Would that be 8 or 1? And make a guess. Don't just wait for the answer. Like, say it out loud. Maybe your mom can hear you. M is 8, and our b value is 1. Thank you. 8 for slope. We can always write this. Please write this also. Change this to 8 over 1, because that's my rise over my invisible run. And it'll make our life so much easier. It'll make our thinking so much easier. 8 over 1. You could also have just done this. 8 over 1 right there. Okay, so you don't have to rewrite it. And our b value is 1. So let's describe what these two things refer to. Our b value is our y-intercept. Well, our y value is right here. And our y-intercept is equal to 1. So at y-intercept, put a dot at 1. Okay. If you draw a cross on your notes, y is 1, put a dot there. Now, how do I get to my next point? Right? Well, that's what slope is all about. It tells you the change. What is my change? The change is 8 rise, 1 run. So I'm going to do that. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, right? And that's 9 because 1 plus 8 is 9. And my run is 1. If I did this without the computer, 1, 2, 3, 4, 5, 6, 7, 8 over 1. That's a pretty steep line. Imagine if this was your job. You became a doctor, you went from 0 to hero. You're making 8 to 1. That is crazy. And here's a cool thing. It'll automatically graph it for us. Okay, so you're gonna have to label what your slope is and what your y-intercept to make sure you don't mess up. And this is what we're practicing, because slope intercept is one of the most popular ways of graphing lines, and we will be doing this all the way to calculus. Next 4 years of high school, you'll be graphing lines this exact way, and it could be this easy if you can get out all the cobwebs now. So I'm going to go ahead and get rid of this. So we said our y-intercept. So here's how fast this is without writing anything. My y-intercept is 8 or 1. we said it was going to be 1, put a dot at 1. And the slope is 8 over 1. So we count up 1, 2, 3, 4, 5, 6, 7, 8 over 1. That's your line. Hope you can see that. Right? My y-intercept, let's double check. My y-intercept is 1. Yep. And we went up 1, 2, 3, 4, 5, 6, 7, 8 over 1. Yep. Okay. My y-intercept is negative 2. So y-intercept, is this negative 2? Is that my y or x-intercept? People are going to make that mistake. And that's fine, as long as we double check it. Okay. My y-intercept is actually over here. Whoops. Negative 2. Now the slope is, look at the slope. What's the slope? It's in front of the x value. M equals to negative 1 over 6. So I can go negative 1 by going down one space from my point. From my point, everyone. From this point, we're going to go down one space over 1, 2, 3, 4, 5, 6. Positive 6. And that's the graph. That's how fast we can graph these lines. Please don't take this like for granted. You guys have to practice this. You guys will be really great at this. But if you don't practice it now, you will feel left behind and feel kind of dumb. You're like, man, this is so hard. You got to practice things when I give it. So we're going to build right on top of it. I'm ready on 19. My y-intercept and my slope. Look at my y-intercept and slope for this problem. My y-intercept is positive 1. That would be right there. And my slope is negative 1 over 7. My rise is negative 1. And my run is 7. So rise is negative 1. I'm going to walk 1, 2, 3, 4, 5, 6, 7 spaces over. We'll tap it again. And let's double check it. Does this line run into y-intercept as 1? It does. Is the slope positive or negative? Double check that. My slope is a negative 1 over 7. That means this guy's losing money. My business is in trouble. It's losing money. Okay, losing money, boss. And is it losing a lot of money? No, 1 over 7 is a small fraction, a small number. So this graph is not tanking. It's just slowly leaking. Okay. That's it for today. What you really have to do now is practice yourself. And the IXL and the values are not super high. They're at 80. Okay.